In this video, I will go over how to find, let me delete some of these, how to find a minimum sample size to estimate a population parameter mu, okay? Two ways to do this. You can either use this formula, which is just a formula rewritten for n, but this is just really the margin of error formula that we looked at today. All right, where are you? Over here. So this formula E equals critical Z times population standard deviation divided by square root of n. What we did is we reworked this formula. We solved this for n divided by critical Z, reciprocate this fraction on both sides, multiply by population standard deviation, and to get rid of this square rooting, we squared both sides. When you do all that, this formula will turn into this handy dandy sample size formula. You can use it. You don't have to come up with this yourself, okay? So that's one method of doing it. You plug in all your numbers in here, okay? So what they will ask you to put in is they're going to ask you how confident do you want to be, okay? Based on that confidence level, 95%, 90%, 99%, you will have a different critical Z value, right? We talked about how to find that during class today, but I'll show you one more time. Also, not only how confident you want to be, but you also want to tell them how precise you want to be. That's the margin of error, okay? And the population standard deviation right there, that will be given to you in the problem. So if you have these three numbers written down, you can just, plug it into this formula, multiply, divide, and square it, and boom, that's going to give you the minimum sample size required to meet that confidence level and that level of precision, okay? But we're talking about sample size. Could be number of people that we need to survey, number of fish we need to capture, or number of individuals that will be in the sample. So you will always have to round up, no matter how small the decimal is. You know how like the traditional rounding rule is if the number is less than 5, then you round down, right? But we're not going to do that. We will always round up for these simple size problems. So that's one way of doing it, plugging things in here, okay? If the population standard deviation is unknown, you can still use the sample standard deviation, little s, provided that a preliminary sample with at least 30 meters. You have, but I think all the examples that you will see today in 6.1 homework, you will be given population standard deviation. So I'll show you how to do the sample size problem using this formula, okay? We can go over this example. Okay, there's only one example here, but I'll also do one homework problem. The researcher in example 1 wants to estimate the mean number of hours spent on required athletic activities by all student athletes in the conference. Remember the example that we talked about in class today? Like there were a conference with, I said, like thousands of students, athletes there, but the researchers only surveyed 40 people, okay? But this time, I think we're trying to do the survey again. Look, how many student athletes must be included in the sample? Okay, so this time we're going to change the sample size from 40 to something else. Like how many students do I have to interview? If I want to be 95% confident, and then the sample mean is within 0.5 hours of the population mean. Okay, so they're giving you that the margin of error, let me go ahead and write down what they gave us. They gave you that the margin of error, oops, not in Korean, in English, E stand for, or E is 0.5. That's the margin of error. And C, the confidence level is 95%, which means critical Z value is 1.96 because C equals 0.95. And you may wonder, where did that 1.96 come from, right? You understand that I'm just using that margin of error of 0.5, but where did I get 1.96 from? Well, I got that from knowing that to have 95% in the middle, take a look. I'll start from scratch again. I'll open up normal calculator and I tell them that I want 95%, 0.95 in the middle. And when I hit compute, ta-da, that's how you look up these critical Z values from normal distribution, okay? If that confidence level is 99, you'll change that to 0.99. The critical Z value you have to use is 2.58. If you want just 90% confidence, then the critical value will be 1.64. Okay, depends on that confidence level, you will get a different critical value. But this is how you can look up the critical values, okay? So that's why the critical value is 1.96. What else I know? I also know that the standard deviation, and this was given to us before, way before. So let me go and find that. But hold on one second. Let me go ahead and put the symbol. Little O with the tail. They gave us this example. This problem gave us the population standard deviation before. Let's go find that. I think it was 2.3. Somewhere we went over this during class together. Oh, here it is. Assume the population standard deviation is 2.3 hours. This was from example 1, right? So I need that number too. So the sample size formula, you need to give them 3 inputs. And those 3 inputs, we found them all. So E is 0.5, Z is 1.96, and sigma is 2.3. All I need to do is plug in these numbers into this formula, okay? So let me open up a Desmo Scientific calculator. Desmo Scientific, and I'll start typing. The formula is, I need to have a fraction, and then I need to raise it to the second power. But what's on the numerator? On the numerator, I need to do Z times sigma. Z is 1.96. Sigma is 2.3. I need to divide this by the desired margin of error of 0.5. So the sample size required is not 81, but remember to always round up. It's going to be 82. Okay, always round up. So if you do that, let me take a screenshot of this and put it in this slide next to it, so that if you guys are looking at the slides, where's that picture? Hold on. I think I lost my picture. Oh, here it is. So that's what we did. That's what we plugged in. The formula is this. This was the formula. And our inputs were these 3. And when you plug all these in, you will get the sample size is 82. And is 82 people. You need to survey 82 people if you want to be 95% confidence and have a margin of error of only 0.5 hours. Okay? Always round up. So that's how you can do this. But I also told you there's another way of doing this. So I'll show you that. So Nicole found this method for me. You will go to stat. You will go to Z-stat. Go to one sample. But look. There is power sample size or width sample size. Oh, I can't remember which one it was. I'm going to go ahead and click on the width sample size, okay? The bottom one. Or it could be the top one. But this is something one of my students, Nicole, found for us. And ever since that, I started using it. So Z-stat, one sample. Instead of width data or width summary, I'm going to click on the width sample size. And I will go and type in everything. The confidence level they want is 0.95. Standard deviation, what was it? I should go back and look at it. Standard deviation was 2.3, right? 2.3. Width is, we didn't talk about it, but we can talk about it now. Look, the desired margin of error is 0.5, so 30 minutes, okay? So the entire interval is going to be twice as long as the margin of error, right? So, because you have to add 0.5 to the right, you have to subtract 0.5 to go to the left. So together you have 0.5 plus 0.5. So the width of the confidence interval is going to be 1. Click on sample size. Ta-da! That's how you can get 82, the sample size of 82. So two different methods. I've been using this formula method the whole time, but since I figured out that there's a way to do this on StatCrunch, if you just remember how to come up with the width is always margin of error times 2, you can use this tool too, okay? Alrighty. And this is just showing you what we typed in. But like I promised, I wanted to show you like at least one more problem on the homework. So let me go open up our class 2.4. And let me open up no, this is 6 chapter. This is chapter 6. Let me open up 6.1 homework and do one sample size problem. All right, hold on. Let me leave the student view. There's so many problems here, but I have a feeling the sample size problems are going to be toward the end. All right. Oh, look. This is a sample size problem. A soccer ball manufacturer wants to estimate the mean circumference of soccer ball within 0.16 inches. They just gave us the margin of error, right? Determine the minimum sample size required to construct 99% confidence interval for the population mean. Assume the population standard deviation is 0.6 inches. So, you have an option. You can go with the formula. You can go with this formula, or you can use this Z confidence interval for mean. I'll go ahead and use this, okay? All right, I'll open up stat, Z stat, one sample with sample size. I'll click that. And once it's open, I don't know what I read, so I have to go back to the problem. All right, this is the problem. Let me open up both of these on the same screen so that I don't have to go back and forth. So what did they give us? They gave us that the confidence level, part A, is 99%, right? So I'm going to go ahead and change the level to 0.99. What about the standard deviation? Part A said assume the population standard deviation is 0.6. Width, let's see, what was the width? The width, they didn't give us the width, but look, they said the margin of error, or they want to estimate the mean circumference of soccer ball within 0.16 inches. So margin of error is going, the width of the interval is going to be 0.16 times 2. Because the width is always margin of error times 2. Okay, so the width is 0.32. And that's all I need to enter. Let me go ahead and click on sample size. Ta-da! They will need to collect sample from 94 different people if they want to be 99% confidence with that level, that precision. Okay, so let me go and type in 94. And that's how you can do this. One more. They want us to now do a confidence interval for sample size of 104. I get this part isn't about sample size. I'll skip it. I'll let you guys do this. But maybe there's another sample size problem. Oh yeah, another one. Determine the minimum sample size required when you want to be 90% confident that the sample mean is within 1 unit of the population mean and population standard deviation is 14.5. So if you have those information, you can go open up stat, Z stat, one sample with sample size. And let's type up everything they gave us. What's the confidence level? 90%. Standard deviation, 14.5. The width though, look, they want to be confident that the sample mean is within 1 unit of population mean. So margin of error is 1, which means the width of the confidence interval has to be double that. So the width is 2. Click on sample size. Oh, they're going to have to collect sample from 569 people. And that's how you can do the sample size problem. So I showed you about 2 problems on sample size. If there's more, if you need help, just write me an email. But go ahead and start working on your 6.1 homework. And just also 6.2 this week by reading the textbook for that hybrid lesson this week, all right?